All right, tonight what we are going to be talking about is stoichiometry. And stoichiometry is one of the most essential things in all of chemistry because it tells you if I want to make so much of a product, how much do I need to start with? If I only have this much amount of reactant, how much product could I make? Or how much other reactant do I need? So what it basically is it tells you how many from a balanced chemical equation to calculate how much through the mole. So how much or how many can I get from this much of a substance of something else? So if we write the for every statements, if you think way back to first semester, okay, if we look at a s'more equation, so what the heck is a s'more? Well, it's always you want some more, right? But what is a s'more? Well, you need 2 grams, so 2 graham crackers, you need 1 marshmallow, and 3 chocolate chips in order to make 1 s'more. So if we look at this, it looks like basically it's a balanced chemical equation. So if I were to translate this into a for every statement, for every 2 graham crackers, I need 1 mole of marshmallows, 2 moles of chocolate chips, and if I have that, then I can produce 1 mole of s'mores. Okay, so the question is, how many grams or graham crackers, G, would I need to use 9 chocolate chips? So we're going to set this up in a dimensional analysis way that we've been doing this whole time, okay? But what we're now going to start introducing is the use of these beautiful coefficients. And it comes from this for every statement, okay? So I have 9 chocolate chips that I need, okay? I don't know exactly how many graham crackers that is instantly, but what I can do is I can do a conversion, because what I do know is that for every 3 chocolate chips, I need 2 graham crackers, okay? So what I'm going to do is I'm going to put 3 chocolate chips on the bottom, and then I'm going to put 2 graham crackers on the top. Okay, where am I getting those numbers? I'm looking at these coefficients. Okay, so now looking at my units, my C's cancel out, and I am left with grams as or graham crackers as my final unit. So what do we get? 9 times 2, which is 18, divided by 3, which is 6. So I would need to, in order to use up all 9 chocolate chips, I would need 6 graham crackers. The exact same thing happens for real chemical equation, and this is the stoichiometry roadmap that we're going to be using throughout this entire unit, okay? What you're going to be doing is you're going to be basically comparing this side, which is the chemical A, and you're comparing it to the right side, which is chemical B, okay? So if I'm trying to go from here to here, I am just focused on chemical B. If I'm going from here on chemical B, moles, 2 liters, I am just focused on chemical B. The problem comes when we're trying to go from chemical A to chemical B. If you notice, the conversion that we're going to be using is this balanced equation. And what we're going to use on those are the coefficients for the balanced equation. The coefficients of the balanced equation allow us to bridge between moles of one chemical into moles of another chemical in a balanced reaction. So let's try to do one of these problems. All right, how many moles of hydrogen gas, so hydrogen gas is this guy in the chemical equation, will be needed to produce 2.5 moles of calcium hydride? So we need 2.5 moles of calcium hydride, which is this guy. When will be produced if 2.5 moles of calcium hydride react with excess water. What that excess water means is that we have enough water, we have plenty of water in order to react to this entire 2.5 moles. So we have a lot of extras of it. All right, so what you're going to do is whenever you're given a stoichiometry problem is you're going to start writing the very first number that I give you, or not the first number I give you, but the number I give you in the problem, okay, which is 2.5 moles of calcium hydride. If I'm looking at my stoich map, I'm not at liters, I'm not at grams, I'm not at atoms. Where I'm at is right here, okay? And what do I ask to go to? I ask to go to moles of another substance. So I only have to go to here. So the rest of this map, all this stuff, is not going to be needed. All I'm going to need is this one little conversion to go from one to the other. All right, so what I'm going to do is I'm going to look at my balanced equation. Moles of CaH2 have to go on the bottom because moles of CaH2 is on the upper left. Moles of H2 is going to go on the top because that is what we're trying to go to. So now I need to fill in my numbers. How do I get them? You're going to look at the coefficients of a balanced equation. So the coefficient for the CaH2 is 1. The coefficient for the H2 is 2. So all you're going to do is 2.5 times 2 divided by 1. So my answer with sig figs is 5.0 moles of H2. So what that means is if I used up all my 2.5 moles of CaH2, I could produce 5 moles of hydrogen gas. All right, we will be practicing a lot more in the upcoming videos. Hopefully you kind of understand where we're getting these conversions for the molar ratio. This is called the molar ratio. It's the ratio found in a balanced equation. Have a great evening.